So good morning, everybody. We are really happy to welcome you all to the seminar on plastic recycling. My name is Avi Blau. I'm the head of the FECA Institute for Circular Engineering and Economy. I'll be your host today. This is the first day of 4 days of really packed seminar, and I'm going to talk about it in a few minutes. But first, to start us off, and it's a really early hour in Europe, we have with us Ms. Roberta De Palma. She's the Chief Technical Advisor at UNIDO, the United Nations Industrial Development Organization. She's going to greet us and tell us a little bit about this project under which this seminar is being held. Roberta, good morning. The floor is yours.
Good morning, Avi, and good morning to all the early birds participants to this wonderful event that we are jointly organizing as UNIDO with the FECA Institute. I'm very pleased to open this event as UNIDO is currently implementing a regional program in the North African and Middle East region called SwitchMed, where Israel is part of the team of pool of countries where we are actively supporting the government to implement, particularly a circular economy plastic initiative. Let me just share briefly my screen for a 2-slide presentation. You have to enable me, Avi.
Yeah, you should be able. Senia, can you check why Roberta cannot share the screen? Yes, now you can.
Okay, good. So as I was introducing, we are implementing a regional program with the support of the European Union and in close collaboration with the other partners like the Environment, the Cirqpack, the Regional Activity Center for Sustainable Consumption Production, and the UNEP. This program is also funded by the Italian Corporation and the Catalan Waste Agency. In Israel, we are closely working with both ministry, the Ministry of Economy and the Ministry of Environment. So overall, the objective of the project in Israel is really try to engage all the actors along the value chain of plastic in order to demonstrate the viability of circular business model. And actually, we are active along 3 main areas of intervention. The first one is completed so far, and it implied the first analysis and review of the current plastic value chain in Israel to understand where are the opportunities for introducing circular business models and what are the challenges that we would like to address. The second area of intervention has been also closed so far, and we have been working closely with the Association of Plastic Producer and Manufacturer in Israel in order to support them in putting forward the guidelines for design for recyclability of plastic packaging, and we have closely worked with them and also with the government to design standards and policy incentives to promote circular economy. And finally, a third area of intervention that also has been completed so far was related to supporting the government in conducting a pre-feasibility study to establish a repeat bottle-to-bottle recycling plant in Israel. Now, when it comes to the phase that has been already completed, we have received a lot of interest from a number of stakeholders to participate further in demonstration activity. This is why we have designed pilot projects that currently are under tendering, so we expect to launch them by the end of this year. And we do have conceived currently 3 different pilots. One is focusing on setting up collection, sorting, and recycling plastic waste from agriculture sector. A second pilot is focusing on circular design of plastic packaging, and finally, the last one is related to logistical and business model for recycling flexible packaging. At the end of the pilot, we will be able to support the government in setting up a roadmap on how to scale up those pilot initiatives to a wider array of also other subsectors, or within the same subsector in the plastic value chain. And we will continue to support the setting up of proper incentive and proper policy regulatory reform to enable the circularity in the plastic value chain. And we all know how the legal and regulatory aspects are essential in order to promote in general circular economy in different sectors. I would like to conclude saying that we are very pleased of our collaboration with the Africa Institute and with both Ministry of Economy and Ministry of Environment. And we look forward to continue our cooperation in the next months, and in particular to support really the country to take a significant step forward the use of plastic. As we all know that Israel is one of the largest consumer of plastic, in particular disposable plastic, in the world. So we see there is a lot of room of improvement, and we are here as the United Nations to support this transition. Thank you very much. Avi, the word is back to you.
Thanks so much, Roberta. And we also look forward to continuing this beautiful collaboration. In the next 2 minutes, I'm just gonna talk to you a little bit about what to expect today and from the project. So just a little bit about us. AFECA is a college of engineering, a public college of engineering in Tel Aviv. We established the Institute for Circular Engineering and Economy in order to first educate students of engineering on circular design. Second, to work with the policymakers, both in the local and national and international level on circular policymaking, and to work with business and industry on integrating design practices in industry. One effort that we're concluding this week is the joint work with UNIDO on increasing the use of recycled plastic in Israel. And this seminar is basically the end of that project. This seminar is packed. I don't know if you had a chance to look at the agenda, packed with content of the leading companies, innovators, researchers in the world on plastic recycling. We have segmented the webinar into 4 days. Today, we're going to mainly discuss waste sorting processes. We're going to discuss recyclable packaging or packaging in general, a little bit on R&D, a little bit on testing. So that's the program for the next 4 hours today. Tomorrow, we're going to go to focus more on recycling, and we are going to talk about chemical, mechanical, and other types of elements in the recycling process, such as washing, and also talk about solutions that integrate recycled material in the product. So not recyclable, but already recycled. Then on the 3rd day, on Wednesday, we are going to talk about business models and the logistical aspect. So we're going to see what happens with agricultural plastic waste. We're going to see what happens in construction. How do we integrate recycled plastic in construction? We're going to talk about the design tool that we've developed for Israeli industry. And in case you haven't seen it yet, we're going to go through the design tool for recyclable packaging. And we're also going to talk about certification. which is something also critical to the Israeli industry. Lastly, on Thursday, this is a day dedicated to policymakers, but as in industry, you're also welcome to join. We're going to talk about deposit return systems, EPRs, how to incentivize industry, how to incentivize consumers to recycle more. Really a packed agenda. Of course, you're welcome to come in and out whenever your agenda and your schedule allows you, but I would stay for the whole 4 days, for the whole 4 hours each day. And what better way to start us off than probably a household name that you all know, the leading sensor-based sorting technology company in the world, TOMRA. And we are very fortunate to have with us Dr. Daniel Schwab. He's the Senior VP for Strategy and Circular Economy. Daniel, thank you for joining us. And the floor is yours. I just want to mention that if you have questions, please write them in the Q&A. We might not have time for questions, but if there's a pertinent question that we identify that it's extremely relevant, we might intervene and ask the speaker to allocate 1 minute to answer a question. So without further ado, Daniel, please.
Okay, thank you. First of all, I hope you can hear me well. Okay,
Yes,
and let me also try to share my presentation. I guess you can you see it in presentation mode?
No, we can see it still in the draft mode.
Yeah,
but if that's what we have, that's okay.
So that should work, right?
Yes.
Okay, sorry for it. So thank you all for having me here. Good morning. You have a very interesting agenda, and actually I think sorting will be one of those red threads which you will see throughout the days. And maybe my role in this is just really to kind of give you a more conceptual overview on sorting, and you will basically see that many presentations might come back to that concept. So I really would like to show you what sorting is and also maybe bust some of the myths which are out there around sorting. Guess you can still only see the first slide.
Yes, we can still see the first slide. If it doesn't work, then just go to draft.
Okay.
Now it works.
So basically, I'm representing TOMRA. As already said, I'm responsible for the strategy of the circular economy division. And TOMRA, who, for those of you who don't know us, we basically have 2 different technical solutions. One is optical sorting machines, which are used in the recycling, mining, and food industry. But of course, today we focus on the recycling, especially the plastic recycling part. And we are also market leader in reverse vending machines, which are used in deposit return systems. Our role in this is that TOMRA is now already 50 years old and basically a passionate leader in that industry. And especially the division where I'm part of the circular economy team, we really focus on collection, sorting, and recycling and look at that from a holistic perspective in order to really create closed loop systems. And basically, many of the presentations you will hear today are either our customers or partners or friends. And of course, the industry is more to that. And basically, we are all really here to help the world recycle. If you think about sorting conceptually, basically sorting is done for 2 different reasons. On the first hand side, you have a recovery of plastics. And again, we are today focusing on plastics, of recovering of plastics from mixed waste streams. And if I say mixed waste streams, it could be different sources. It could be waste which is already separated, so source separated plastic packaging. But it could also be plastic which is recovered from mixed waste, so from residual household waste. And I come back to that later on. So that is one part. Let's call it primary sorting, where you really recover the plastics from waste streams. And then the second part where sorting is applied is when during a recycling process, mostly the mechanical recycling process, where you basically increase the quality of the material throughout the process, and basically where you would do also different sorting steps, and I come back to that later on. From a conceptual point of view, sorting has basically different elements. So you need to provide the material in a nice uniform way. Then you always have a sensor. The sensor will then, based on different technologies, identify the objects. And then image processing will then basically take a decision into what is good and what is bad. And then you have a mechanical means to separate the material into two or many more different fractions. And basically, when it comes to transportation, there is different means. Either it could be on a belt or it could be on a chute. The chute system is smaller in footprint. The belt system is larger. You would use a belt for material which is not uniform and which basically does not behave in a uniform way. So for example, if you sort out your waste, you have different kinds of objects when you need a belt in order to be able to separate it. And if you have smaller uniform objects like flakes, you would use a chute-based systems because where everything flows nicely and where it's easier to use it in a chute setup. When it comes to the detection, there's basically many different sensors available today, and basically it's across the electromagnetic spectrum. For plastic, the state-of-the-art technology which is used is near-infrared spectrometry, where you basically can use the spectral information to differentiate different types of plastics. But you can also use with color cameras, for example, to discriminate the color. And there is a whole of other technologies which are then more or less used in other applications like X-ray, which is used in metal sorting. You could also have electromagnetic sensors. You could also have lasers, laser fluorescence, and other things. But again, for plastic, it's mainly near-infrared spectrometry as well as visible spectrometry, which is used. When it comes to the ejection, there are basically two kinds. The most common one is the air ejection, where basically you have a valve block with many different valves. And depending on where the object is, it's ejected. So this is already state of the art for 25 years. And what lately has been introduced to the market is also using robot arms for ejection. Pros and cons. The disadvantage of a robot arm is that it's rather slow, so you can do kind of 1 to 2 picks per second. The benefit is that the robot is more compact, and the robot could do the sorting into many different fractions. While the sorting with valve blocks, basically you can do it at a very high speed. The disadvantage, it takes a little bit more space, and you can only do sorting into 2 different fractions at the same time. So you need multiple sorters to do the sorting into more than 1 fraction. So this is currently one myth. You see a lot of fuss around robot arm sorters being the next big thing, but actually it's just a complementary product compared to the conventional sorters. And basically, as I said, both technologies have their pros and cons, and they will basically serve different applications in different positions of the sorting line. So it's not one or the other, it's basically kind of both. When you then come to a sorting concept, and I guess that my colleague afterwards will dive more into that, but basically a sorting plant has many different sorting steps, and not all of them are sensor-based. Of course, there are also mechanical or physical separations like sieves or magnets or other things. And then, especially when it comes to the separation of plastics, then you use the sensor-based sorters. So in a typical MRF, again, the material flows over different sorting steps, so that at each sorting steps, you're sorting something out and the rest goes on, and then you basically create more or less the different kind of outputs. And at the end of the day, it's really about your kind of economy and economy scales, how many outputs to create. So the latest sorting plants, the biggest sorting plants could easily have 20, 30, 40 or even more sorters present. Here is the example of a mixed waste sorting plant. So again, mixed waste means it's residual waste. It's not a source separated plastic fraction, but this is really the mixed household waste. This example is based in Norway, where we have several plants operating on that concept of mixed waste. And here, for example, 22 sorting units are used in the concept. And the takeaway is that today it's economically feasible, but also technologically feasible to recover plastics out of any waste stream. So even if you have a totally contaminated waste stream where everything goes to one bin, and we also have such plants, for example, in the Mediterranean, in Greece, it's possible to extract the plastics out of a very dirty waste stream. That's not a technical problem anymore. This is solved. And it's done in many plants worldwide. When it comes to recycling, so this is the illustration of the bottle-to-bottle recycling for PET. So I'm pretty sure you are all aware that PET can be recycled back into, or PET bottles, beverage containers can be recycled back into PET bottles again, even with food grade in Europe. And basically here, the concept is that your material is collected either, for example, from a deposit return system or from our systems. And when it reaches a recycler, the first sorting step is what we call a bottle sorter. So here again, the bigger contaminations are taken out. So for example, there might still be some non-PET bottle objects which are taken out from the first sorting step. Then comes shredding, washing, drying. Afterwards, you have your flakes, and then the flakes are running over additional flake sorting steps where then all the remaining non-PET material is taken out. So that could be material from the caps, it could be material from the labels and other stuff. And then you would go into extrusion and then creating PET, recyclates. So basically in that process, it's state of the art to basically have one sorting step before the shredding and washing, and then one sorting step, several sorting steps afterwards. Another example, now, as I said, PET bottle to bottle is state of the art. So we also work for RON, for example, to discriminate PET bottles from PET trays, thermoforms. You might know that many people believe that PET thermoforms right now cannot be recycled, but this is not true. And we see now the first recyclers who really go for PET thermoforms. And again, from a technology, it's possible to differentiate, to sort PET bottles from PET trays, and then to also bring the trays back into a closed tray loop, similar to the bottles. Another example that is to do high quality recycling, not only for PET, but also for polyolefins and other plastics like polystyrene or polyamide or polyurethane, etc. And there we have teamed up with Borealis and creating a demonstration plant where we show that with the right sorting, washing, and extrusion, you can also reach high quality recyclates with any other kind of plastics. And again, today you will hear a lot about those. I think there will be a presentation from Nextloop and also one from Morsinghoff. So I think that concept will also be explained later on, but really there is no reason why other polymer types than PET cannot be brought back to high qualities with the right process parameters. There is also a role for sorting in chemical recycling. And basically there it's about, we have to capture the feedstock. So again, you need to do a sorting of, for example, household waste to recover plastics to make it available for chemical recycling. And then it's also a matter of preparation of feedstock and quality control. You might know, or you might hear it the next couple of days, that also most chemical recycling technologies cannot take a totally wild feedstock, but they also have certain quality specifications like PET or PVC might be an issue in, for example, pyrolysis. And then you also need sorting to make sure that you don't have too much PET or PVC contamination in your feedstock going into your pyrolysis. So maybe to kind of conclude, what is state of the art? So it's state of the art to extract plastics from any other kind of materials. It's also state-of-the-art to sort plastics by color, but also by plastic types, sort out rigids from flexibles, and we even can go one step further to differentiate PET bottles from PET trays. What's the future? The future is to do even better sorting. So for example, sorting by melt flow index to at least differentiate blow molded versus ejection molded objects. Another big thing to be done is sorting of food grade versus non-food grade. This is, for example, necessary under European legislation on food grade, that you need to make sure that something was food grade before it goes back to food grade. And it's also about identification of objects. And technologies to do so are already known and worked on. You can do that with a deep learning, where basically you teach your system and you teach, okay, this is a Coke bottle, this is a detergent bottle, etc. It's also being worked on with digital watermarks. You might have heard about the project called Holy Grail, and now Holy Grail 2.0, which is working on digitally marking objects, which could then be identified in the sorting process. And the third method to achieve this is with tracers and markers. And again, you will later on hear about Next Loop, who would basically use some fluorescent markers in order to identify different features which cannot be identified with conventional sorting processes. So my summary is that sorting technology already can solve a lot. And most of the problems today can already be solved from a technical point of view. So sorting is currently not really the bottleneck. The bottleneck is more around the economics and the economics in sorting something. So that would be my main message to you. So are there any questions?
Perfect, Daniel. Thanks for this presentation. I think you've broken or challenged a lot of strongly held conceptions in the sorting and recycling domain, which is really, really interesting. If there are no questions, I want to take the opportunity to ask you for me, the $1 million question, not many opportunities that we have to speak to Tomra. What do you think is better, the separation at the source or sorting at the MRF through the mixed municipal waste?
Let's say from a fundamental point of view, the sorting at source is maybe not really needed. So if you start from scratch and you wonder about Indonesia or Vietnam where you have nothing, what should you start with? Maybe you would really start with collecting the waste and then sorting it out later. Of course, if you have already established a source separation systems like we have in Europe, of course, it would be stupid to abandon them. So of course, we have advantages as well, and it makes recycling easier. But let's maybe put it like back source separation makes recycling easier, but not source separating does not make it impossible. It just means you need to have more effort on the recycling side, better cleaning processes, better sorting, better washing, etc. So let's say it's helping. And of course, if you have already done it, you should keep it, but maybe it's not absolutely necessary if you really start from scratch and you're wondering whether you should have 2 bins or 5 bins or 20 bins in a country which has currently nothing.
Yeah, I guess you don't have any analysis or specific answer for Israel. What would be the best strategy for us right now?
But maybe what we should, of course, say, we now talk about plastics. Of course, for example, on paper or textiles, there are, of course, waste fractions where the source separation makes lots of sense and is necessary. Of course, if you mix organics and paper, the paper cannot be recycled. So it's absolutely clear that certain things have to be source separated, or batteries or toxic stuff. But maybe on plastic, it's not. From the research we did together with Eunomia, it was shown that on plastic side, it's not necessary to do it. But again, you might do it for other reasons.
Yeah. We have maybe 1 or 2 minutes. So we have a question. We have a question here from Nick, who is asking about the marker on the packaging to enable better recycling and sorting. And he's asking which is better, image recognition or AI, or marking the package, and is it adopted already? What are the problems with this approach?
Image recognition is now rolled out as we speak, but of course it's difficult because there are so many different objects, and of course the object can be damaged and dirty in many different ways. So basically it's right now teaching the system object by object. So until the whole waste is identifiable, it still will be many years ago. And of course, the challenge there is really teaching the system. I think the algorithms are known, but now it's just the homework which needs to be done to teach the system. Digital watermarks or other kind of watermarks are interesting concept. The question, of course, is who's financing it. So would you introduce a watermark just for the sake of recycling? Maybe not, but of course, for example, technologies like Digimark also have advantages in the checkout or in consumer engagement, and they might be anywhere. And then, of course, it makes sense to also adopt it. But of course, what makes it challenging is that now all MERS would have to adopt it. So it does not help if Unilever is doing one thing and Procter & Gamble is doing something else. Of course, the whole industry has to agree to one standard. And then also the whole waste industry then has to use that standard and then apply those machines and upgrade the machines, etc. So of course, it's also challenging. So maybe image recognition is the easier way for the moment. But again, we have to see, and people are working on all concepts at the same time, as nobody really knows what the winner is. But of course, it will solve some problems in the future if it will be pretty sure that in 10 years' time, we can identify all objects. It's just a matter of what is the winning technology.
Great. Fabulous. Thanks for this answer and for the presentation, Daniel.
Thank you.
Thanks for your time. We move ahead to Suez Cirqpack. That's a company that specializes on circular packaging, daughter company of Suez. And we have with us the CEO, Vincent Mui, who is also an esteemed member of our consortium for this project with UNIDO and a great colleague. Vincent, good morning, and the floor is yours.
Good morning, Avi, and thank you for letting me be here. I'll start with sharing my screen. Hopefully that works. Okay for you, Avi?
Yes, perfect.
Yeah, perfect. Good. So I'll start with a very short introduction of Suez Cirqpack. Suez is one of the largest waste and recycling companies in the world. And Cirqpack is completely dedicated to giving advice on recyclability of packaging. So we support brand owners, retailers, and packaging companies who are looking to create more circular packaging. And we do that with workshops, masterclasses, packaging advice, certification on recyclability of packaging. We also have a lot of knowledge on what's happening in different countries. It's part of our country overviews, and we have a huge amount of big data on packaging. So we know for most of the packaging how it's being sorted and to which reprocessor it will go. We always start about talking about recyclability, but what is recyclability? When is some packaging or plastic recyclable? There are basically 4 criteria that need to be met. First step is that the material needs to be collected, and that's really depending on the country. That can be a serious problem. There are countries where there is no infrastructure for collection, and of course for other countries that is relatively well organized, but it can also be with deposit return systems and other options, take back systems to have this done. Then the material needs to be sorted into the right material family. As Daniel from Tomra just explained, that's where the near-infrared technology comes into place, but other technologies as well. And then the material will be going to what we used to call a recycler, and I rather call them a reprocessor, because that's the part of recycling that they do. They reprocess the material and they purify it to a certain extent to make sure that it can be reprocessed. And finally, of course, we need an application, because otherwise, if it's not being used, it's also not recyclable. And only when these 4 criteria are met, then we can consider something recyclable. And today, I will focus on the sorting. And this is the sorting part mainly of the complete packaging. The process that follows before it goes to a reprocessor. Now, here is an overview, schematic overview of the process of a sorting facility. And this sorting facility is, this one specifically was built for plastics, metals, and beverage cartons. There are other countries or other lines where you specifically also take in glass, for instance, or cardboard together with these plastics and metals. So the technologies that are in place in this one might differ a bit from the others, but generally these technologies are used worldwide in different industries. But as soon as you have an automated sorting system for packaging waste, these are the technologies that are in place. So the waste gets unloaded from the truck to the facility, and there we do a quick inspection. We take out some unwanted materials, large pieces of garden furniture, for instance, or metals, but also huge pieces of film, and the rest will be put into the bunker. And this is pushing forward very slightly, very slowly. And then you have a bag opener, because people put their packaging waste in bags. These bags need to be opened because we want to identify each packaging item individually. So that's why we actually have another bag opener, to ensure that even if people have put it into 2 bags, everything will be separated before it enters the rest of the process. Then the first big thrummel is being entered, which is a sieve drum. And the sieve drum is a big rotating drum with small holes at the beginning, large holes at the end. So with that, we get size sorting. And what it helps for is to really take out the fines, the small materials, which are basically contaminating the recycling process. So there's a lot of dirt, pebbles, and organic fraction that is unwanted in recycling. And by having a minimum threshold of, well, depending on the facility, somewhere between 2 centimeters and 5 centimeters, you take out everything that is smaller than that. And you're only focusing on the larger components. Then we have additional wind sifters, and the wind sifters basically separate the very lightweight material, which they can suck up, versus the more rigid or heavy pieces that will fall down. By doing that, we are basically left with more rigid material. Going to number 7, which is a magnet, taking out all kinds of ferrometals. Then we go to this first NIR, the near infrared. That could be a TOMRA one, but it could also be one from Pelenk or TTEC or another company. This one taking out beverage cartons, looking for a specific combination of PE and carton. And that combination gives you a certain near infrared spectrum that allows this system to recognize them and shoot them out. After that, we have the eddy current, which is basically, you could call it the magnet for non-magnetic material. So it gives an electrostatical charge to aluminium and makes it jump out by this electrostatic charge. An additional ballistic separation, just to make sure that with this wind sifting that we did at number 6, we actually also have taken out all the rigids and did a good separation of the rigids and the flexibles. And this is basically by the moving arms, which pedal in a certain under a certain angle, which makes the lightweight packaging go up and the rigid packaging go down. All the rigid packaging will go to a couple of NIRs, and each NIR is set for a specific material. This could be PET, it could be PE or PP. Some countries you also see that they have a dedicated separation of polystyrene. We see more and more that there's an additional PET separation in PET bottles and PET trays. And also that on the flexible fraction, so the films, you also see that this NIR sorting is done for now mainly on the LDPE. But in the future, we also expect that there will be mono PP films taken out for recycling. After all this, we go to the quality control. That's basically the only human interaction you have in these facilities. Basically checking if really everything was sorted correctly by the process. This is indeed also where robotization is taking place just to with these arms, robot arms, removing material into the right fraction. After this final inspection, the material is sent to a baler, which creates these big bales ready for shipment into a certain material fraction, and they're going to the correct reprocessor. Now, again, just as an overview, this is one of those sieve drums. Here you see it on the outside, and this is the inside where the material comes in. The smaller holes on this side, larger holes on this, and everything will be sorted by size. We take out all the fines on this side, and the really large pieces come rolling out here because they cannot enter the sieve drums or the holes. In each sorting facility, you see these big tubes running to the facility. And this is basically where these materials the lightweight materials are actually sucked up and transported to a bunker or a conveyor belt where all this material comes together. And that's a good way of doing a first separation of the lightweights from the rigids. The overbelt magnet, materials on the conveyor belt, a mix of materials, and just this magnet is on top of it, picks up the ferro metals and releases it afterwards, and that's how you get a separation. Yeah, let it fall after the threshold. Similar thing, but now with eddy current. So there's no magnet on top, but there's an electrostatic charge created underneath, which actually makes non-ferro metals jump out. They want to get away from this electrostatic charge. Here we actually see that there's a difference in behavior between the rigid pieces and things like film, which are more flexible and larger. And that's basically like having an apple fall from a tree or a leaf fall from a tree. If it's an apple, it will fall down in a straight line. So in this case, it's much easier to eject over the threshold because it will go out in a straight line. And if you have a flexible piece of aluminium film, it will react, but it will probably not pass in a straight line. It's got too much friction in the air, so it will most likely fall down already. So here, well, I'm not sure even if the source was T-Tech or Tomra, looking at the previous slides of Daniel. But indeed, this is what the representation of the infrared system, where we can see this picture. So we see this Coca-Cola bottle there. And this is sort of a representation of what this infrared system sees. And you can already see there that indeed, we know it's a PET bottle. And that's correct because it's green on both ends. We also see that there's some blue on top. So it must be an HDPE cap. And then this sleeve, there we get a mixed image because the system actually doesn't know what it is. It's really a combination of materials. The depth at which it is looking is somewhere between 80 and 100 micron. So every material in between this 0 and 80 or 90 micron, he will get a reflection of. So it basically is looking at not only the sleeve, which might be 45 micron, but also on the PET bottle underneath. And that's why he gets a mixed image and is not entirely sure what this looks like. Well, there are new technologies upcoming indeed to get a better recognition on this. And luckily, because it's got PET on both ends, the system knows that they should sort it as a PET bottle. But you can imagine if you have a full body sleeve, really from the top to the bottom, that it might be very difficult to do so. And carbon black is actually one of the things that are really hard to detect with infrared. And that's what we also see in the standard design issues. Because these are basically materials or packaging that are really, really hard to sort. Sometimes it's completely impossible. Sometimes it depends on consumer behavior. And here one of the things that we have seen a lot in the past, and that has been changed already by a lot of brand owners, is that they used carbon black in their packaging. And by having carbon black in your packaging, you actually have something that is a really deep dark color. And why is it such a deep dark color? Because it absorbs all the light, and it not only absorbs the normal light as we know it, but also UV and infrared. So also for the installation, the near infrared installation, it's really hard to recognize these materials because you don't get any reflection of the material itself. So that's a big no-go. Another one is on product residue. We see, for instance, with sauces, tomato ketchup, mayonnaise, but also with honey, that there's still a lot of product residue in these packaging. And as they become very heavy, if there's still a lot of material attached, they will not always make it over the threshold when they are being shot out. So they can be recognized, but the actual ejection can be a serious issue. This is another problem for very rigid and round packaging. If you look at, so although there's quite a big sleeve on here, but if this were just completely plastic only on the outside, it would very well be identifiable probably as PP packaging. However, this is very round and rigid. So this is the kind of bottle where if you would stand on it, it would not change shape. Meaning that when we put it on a running conveyor belt, this bottle will actually start rotating counterwise, anti-clockwise. So if it passes this infrared scanner, it might see it, it probably will, and tries to eject it, but it's actually rotating a bit back. So the ejection is not accurate enough to shoot out a round packaging. Obviously, it's already hard to shoot out something that's round, but especially when it's rotating in another direction, it's very hard. So everything that's compactable is much more easy to separate. Aluminium film, basically, as I told you, yes, we see some movement at the eddy current, but typically not sufficient enough to take it out as alu film. And then we have those with large sleeves and labels. You see all these full body sleeves, which make it harder to detect. And I know the systems have done serious work to improve this, but it's still an issue for a lot of packaging. And also on this one, there's actually a very large sticker. So the print might not be too big, but there's a really large sticker on this packaging. These are really big issues in the sorting, and well, they can luckily be made up partially by new sorting technologies that are upcoming. Already discussed robotization, image recognition, and deep learning, which will be really helpful in understanding the packaging, not only in positive sorting, but also negative sorting, meaning that if you, for instance, silicon sealant tubes are typically made in PP, and silicon is something that you don't want in your in between your melted plastics, because it will not melt. So it causes a lot of issues at the extrusion lines. So if you can already take it out by just knowing, hey, this is the shape of a silicon sealant tube, and these are the brands, and this is what they normally look like, that can be very helpful to separate them. Another thing indeed is all these digital watermarks. The Holy Grail 2.0 project already mentioned. So there's a semi-industrial scale pilot ongoing in Copenhagen at the moment. And it basically, you have these packaging, which for the human eye, they look completely normal. Only if you look very carefully, you see that there are small dots in certain patterns, which makes it actually behave like there is barcodes all over these packaging. And these barcodes give information to feed to the system, the sorting system, but also to the cash register at the supermarket on what to do with it. Yeah, and if we typically look at the sorting only, it might be very interesting to say, okay, you might see me, especially if, for instance, with these full-sleeved bottles. You see, you might see me as a PE sleeve or PE bottle with near infrared, but please sort me into the PET, because underneath there's a PET bottle. And by the way, don't put me in the food grade, because I actually contained washing detergent. So put me in the non-food grade. Yeah, these are the additional things that you can do with this. Whether this will be based on these digital watermarks, or indeed on deep learning, artificial intelligence, and computer vision, I'm not sure. I think everything will work together in the end. I strongly believe that the companies like Tomra and Belank are fully on board on this, and that they will integrate this into one system in the future. So the near infrared that we currently talk about, which mainly is looking for indeed the near infrared spectrum, it will combine near infrared with artificial intelligence or computer vision and digital watermarks. How long will it take? Well, that's more a business case question, because every additional sorting step.
Vincent, I want to intervene. We have 1 minute.
Yeah. I'm I will get there. Thank you.
Thanks.
So after all this sorting, material will go to a reprocessor, and even there you see that a lot of additional sorting is required, because more than 80% of recycling is about sorting. And how much needs to be done really depends on origin of the waste, the quality of the input, but definitely also on what is desired, what output is desired, and for what kind of application am I working. Yeah, so that's an important thing to understand. But that's will come on later during these days. Just for your information, I would like you to understand that there are huge differences throughout the world. So really understand your local market on producer responsibility system, but also on these EPR fees and taxes. Recycling results can differ hugely per country. And of course, what is collected in this country? How is it collected? Is it part of a deposit system or not? Is it curbside collected? And which materials are actually being sorted and reprocessed? And all this combined will define what you have to deal with as a brand owner, but also as a packaging company to ensure recycling.
Fabulous, Vincent. Thanks. Thanks so much. Just to say that we don't have time for questions, but just to say that many of the topics that you discussed are integrated in the design guidelines that we have produced together with you and with the Israeli Packaging Institute, which will be presented on Wednesday. So a lot of this information is already available to you in Israeli in Hebrew, and actually also in English. Thanks, Vincent. Good to see you. And we go now from Suez Cirqpack to Suez, the company itself. And we have with us Stuart Hayworth. He's the Technical Development Director at Suez Recycling and Recovery UK. Suez is, of course, one of the world's largest environmental solution companies. And we asked Stuart to take us through the issue of flexible packaging, which is seemed to be a major challenge for the sorting and recycling system here in Israel. Stuart, hello. The floor is yours.
Thank you. Let me just get this presented properly. So that should be in full screen, hopefully.
Yes, it is.
So I'm going to take you through the work we've been doing for the UK. So the UK market for flexibles, very little of flexibles in the UK are collected. Where they are collected, it's generally films that are collected rather than the actual packages themselves. So this is the journey from a country that it hasn't really grasped the collection and sorting of flexible packaging itself. So first off is we need to understand where in the system flexibles will fit, how much arises from households, from household likes, that's businesses, but where the waste in the businesses looks like household waste as against pallet wrap and etc., which fits in the commercial packaging. So separating those to understand where the materials arise and how much of those will actually get through to the different streams that we're we're collecting. So we did a lot of work. We did top down. Placed on market figures are quite difficult to identify because you can't really understand what you want to collect until you understand what's placed on market. Not many organizations seem to have a good grasp. So we did top down first, 3 or 4 different ways. And then we did a bottom up. We went and did some, collected some detailed composition analysis of how much flexible packaging of what type appeared in the residual waste, i.e. that's not going to recycling, and how much appeared in the recycling waste, which gave us a good grasp on the composition by all the different packaging types. And then for ease of management in not only this work, but also the work we've just completed on the industrialization, which I'll come to towards the end, we split them into families, because once you've got them into families, you can understand how each of those families is going to be treated and where its end market will be in that process. So it gave us the ability then, if you see in the flow diagram 2A, how those materials split out, how they're going to be collected. We used that, some of the information that Vincent and his team have got from other sites to help us put that together in terms of what would arise, what size would arise, because size becomes important, and what we can do with it in the end. And you can see here large films going to virgin polymer replacement, and then as you get smaller and more complex materials, it's going to wood or concrete replacement. Ultimately, in this example, that's too small or too mixed, going to energy recovery. So how you collect determines what you want to sort. So if you collect the materials on their own, so source separated, then you don't need a sorting plant to separate them from the other hard recycling materials. If you collect them commingled, mingled with other materials, be them mingled with other plastics or mingled with other materials beyond plastic, then you need to design your sorting plant to separate them from that stream. What you need to do though is make sure that we don't have fiber products mixed with the flexibles because of the 2D nature that they present. So again, looking at that, looking at how many packs, looking where they arise, and understanding in detail. And one of the key things is also what product they had in them. Generally, users of packaging that has wet product in it, such as cat food or dog food or toothpaste, tend to leave a fair volume of the product in the material, in the packaging itself, which creates issue on the collection of smell, leakage, and therefore contamination to other products. So we split also not only in the families you've seen before, but we split them into dry and wet to represent their likely composition of contamination that was going to come in, that was in the packaging in the first place. We've done a number of trials in the last 5 or 6 years, and where we've done collection trials from householders with wet flexibles or flexibles containing residues of wet products. We found that we've had to collect them weekly rather than 2 weekly. Whereas if you have dry flexibles or flexibles that have dry products in them, then you can actually collect them every 2 weeks. So you then have to understand the frequency and the style of collection. In the UK, it's common that residual waste is collected every 2 weeks, and dry recycling is collected in the alternative 2 weeks. So if you're doing a weekly collection because you have wet flexibles in there, then you need to have a separate form of collection, or you need to provide a parasitic collection on the existing trucks. And what we needed really to understand on the collections, volume collected per household, because that gives you service quality in your truck, volume needed per truck, i.e. how much space you need to allocate in your truck, and the collection method, which all flows into how you then sort. We then created some high-level families of how materials will be collected. And again, there's a range of different ways in the UK that we collect materials from households and from businesses. So mixed with other materials, except card, collected plastics only, either on their own or in a bag, or in a survival bag, where we take the bag out and send the bag off to be treated. And obviously that requires therefore different transfer station where we bulk up, and simple or complex sorting, depending on how we've collected it and what we've collected it with. And we need to understand that to understand what our role is. And then obviously, once we've collected our materials, we need to understand what end market we're going for. Are we sorting for mechanical? Are we sorting for a blend? Or are we sorting for chemical recycling to get into our end markets? So we ran through a series of designs. Here you've got one based on our Rotterdam plant that we had, and another on our Oberon plant that we had, where we looked at the difference between the two. Was obviously different plants, but Oberon went down to a smaller size. So we're then sorting and collecting to look at where those end products would be. And if you look at 1A, you can see how the large films flow through an example through an LDP or PP recycler. We gave some examples of those companies that offer those services at the moment, and the end market, i.e. virgin polymer replacement. When we got to medium films and flexibles, 50 mil to less than 300 mil, or greater than 50 mil to less than 300 mil. Some of those could go into the virgin polymer, but some of those were going into wood or concrete replacement. So again, going through those options to understand what we're going to recover for. And for EPR, where the recycling rate, actually recycle rate is important, the volume that goes into energy from waste, which is obviously recovery, not recycling, was material to understanding meeting some of the EPR and the recycling targets. We then looked at mixes of chemicals, so same flows, splitting them between different types of polymer and film and different sizes to understand where they might end up. And you can see here, if I look at 4, how some of the materials that previously were going to either virgin polymer or to board replacement, for example, can now be made through chemical recycling into food grade polymers, which is just starting to emerge as a solution, others into oils, fuels and waxes, and then some particularly where the aluminium is recovered as well in that process, and reducing the amount that goes to energy recovery in small flexible components. So again, working through each of those issues to understand how we would A, collect, B, then need to sort, and see what we were sorting to in the market. Ultimately, we ran through 12 different options. If you want to, I've shown a copy of the report. We had to look at those 12 as the main routes to market for flexibles in the UK, based on different local authorities. If you're collecting from a very urban area, from a city, then your options of how you collect are very different than if you're working in a suburban area or a very rural area. So it's key, therefore, to understand how your source market is going to work. And then also, if we're going to chemical recycling, we're then looking at how do we measure that? So if we go to chemical recycling to fuels, then that's recovery. So that's not currently classed as recycling. There's some process losses in there that are either used to fire the process or are unacceptable. And then you get, if you put it into a refinery, the refinery has its own process and looking to effectively hypothecate end products so that you can allocate 1,000 tons in, you can make 1,000 tons of recycled product. Again, making sure that process flow and mass balance flow is acceptable to the regulators that will ultimately allocate the recycling content of any products. So when we looked at, coming back to this one, just a reminder, we looked at mechanical and chemical and how the mix and the size. So the work we've just completed was complete industrialization. So we've been through every local authority in the country, which is more than 350. We've been through all the different styles of business to understand what they're likely to collect, what they're likely to produce and when. And then we've looked at how those flows need new infrastructure and new processes. So if I take the top one, separate flexibles, that's where we collect them in a bag. They can go through a transfer station, don't need to sort them because they're already pre-sorted by the waste producer. They go direct to film and flexible processors where they're washed and separated, and then use basic mechanicals into polyolefins and advance mechanical and chemical into different products. And we looked at that through a number of different, so mixed with other plastics and cartons, fully mixed with other materials except paper and card. And then we looked at an add-on option of wet flexibles collected separately. So wet flexibles in a bag and dry flexibles with the remainder. So a mix of a bag for wet flexibles and then 2 or 3 for the remainder, and to work out the cost and the profile of doing that. We then had to look at sorting yields, mechanical and chemical. So working through what we expect to get if we're sorting to less than 50 mil or less than 25 mil, so 80 or 85%. What the mechanical reprocessing yield is likely to be on average, 80% to allow for. And then chemical recycling, which current activity, and we have our own chemical recycling process, is around 85% at the point that it enters the plant. So overall yields, so 80% sorting and 80% of the materials passed through sorting being reprocessed gives you an average about 64% upper performance for mechanical, and 85 by 85 gives you about 72% for chemical. So chemical has the ability to deliver a slightly higher recycling value than others. So what does that mean in summary? So collection of feedstock drives the sorting end markets. So understanding how it's going to be collected, understanding how you get the behaviours right to get people to put the materials in the right bag in the right place. Clear signals about collection will engage investment. If you understand how you're going to collect it, then the investing requirements for the sorting plants, for the perf sorting plants, etc., and the chemical recycling is there. Chicken and egg is collect first, and the markets will follow. Chemical recycling does offer key to upcycle and deliver virgin polymer quality and outcomes for some of the feedstocks, and gives somewhere between a 5 and 10% uplift in ultimate recycling performance. Obviously, there's a lot of proving to do on chemical recycling to make sure that we can actually achieve the qualities and the reliance and the commercial outcomes that are needed. In all chemical recycling, some materials may end up as fuels, as waxes, still productive, but obviously not counting towards recycling. Policy visibility and transparency super important to drive the investment, and there's a significant numbers of hundreds of millions of pounds in the UK sector to get flexibles collected and sorted and recycled. And in designing the transition, nothing happens immediately. So we think it'll take maybe 5 or 6 years for all the local authorities in the UK to implement a collection system that allows and supports the sorting and treatment infrastructure behind it. And we think business will probably be roughly on the same profile based on the fleet replacement age. So planning that transition so that we can go through the whole leg, not have facilities with no feedstock, but then have no but don't be in a position where we have feedstock and no treatment. So that's quite an important part, and that's why we've been doing and have finished the second supplementary report, which I'm currently writing, and will be published this side of Christmas. Thank you very much.
Great, Stuart, thanks a lot. This is a very timely presentation and topic because there is now a UNIDO-driven project exactly on this topic of flexible packaging in Israel. So we will probably be also in touch, we'll be happy to be in touch in the future, in the near future to ask you some questions. There was a question in the chat, but unfortunately we don't have any time left. So if you could be so kind to look at the chat and try to answer that question. Thanks a lot.
No problem.
Perfect. Thanks, Stuart. And we're on to the last presentation before the break. And we have with us Dr. Marcia Scopelliti. She's the project officer at Plastic Europe, which is the European Association of Plastic Manufacturers. And we asked Marcia to speak about design for recycling. After seeing the infrastructure, we want to see also the other side of the design phase. Marcia, hi. Thanks a lot for joining, and the floor is yours.
Thank you very much. So I hope you can hear me.
Yes.
Okay, so I'm just trying to share my slides, but I'm not sure you can see them.
Not yet.
Moment. Okay. 1 second. Now they should be on.
Perfect. Yes. Now it's on.
Okay. Okay. Thanks a lot. Can you see them full screen?
No, it's still in draft mode.
Okay. Now
it is. Yes.
Okay.
Yes.
Perfect. So first of all, thank you very much to the organizers for inviting us. As said, my name is Marta Scopelliti. I'm project officer at Plastics Europe, and I mainly work on end of life and circularity. So before getting to the content of my presentation, I just wanted to spend a few words on who we are. So as mentioned, Plastics Europe is the pan-European association that represents plastic resin manufacturers. And in fact, we represent over 100 companies covering 90% of all polymers produced in Europe. We work closely with the value chain to deliver solutions which are safe, circular, and sustainable. And we also operate in 5 different regions in Europe, including the UK. And today I'm presenting actually from our headquarters in Brussels. So as mentioned, I will be presenting on design for recycling. And for that, I would like to start to start by presenting what Plastics Europe is doing on this subject and how we are engaging in different European-led initiatives related to design for recycling. So first of all, in 2018, Plastics Europe has developed voluntary commitments for its members. So we made pledges in very different areas. First of all, we pledged to accelerate innovation across the full life cycle of products. So we really want to improve the resource efficiency and the circularity of plastics. And for that, we aim at reaching in 2040 that 100% of plastic packaging are reused, recycled, or recovered. And we also set an intermediary target of having 60% reuse and recycling of all plastic packaging in 2030 already. We also continue to develop our program to prevent the leakage of plastic into the environment. So for instance, to date, 100% of our members are already signed up to the Operation Clean Sweep, which is a voluntary program aimed at preventing pellets loss in the environment. And we are currently in the process of developing a certification scheme dedicated to this program. And finally, we pledge to increase our engagement inside and outside our industry. And for that, we cooperate with different international industry organizations, such as the World Plastic Councils, but also the International Council of Chemical Association, mainly to support initiatives related to marine litter, but also to promote circularity more broadly. So in addition to these pledges, a number of European platforms that you see on this slide have also established commitments to stimulate the increased recycling of different plastic types. So these are really sector-specific and polymer-specific commitments that have been developed by different organizations. So for instance, the polyolefin circular economy platform, but also styrenic circular solution and the vinyl circular solution. So they have all very specific focus on different polymers and very different commitments for the recycling of those polymers. So as I mentioned in the introduction of Plastics Europe, we work closely with the value chain to deliver solutions which are circular. And a clear example of how we engage in circularity beyond our industry is how we engage in the Circular Plastic Alliance, the CPA in its acronym. This is a European initiative that was launched by the European Commission in 2018 as part of the European Plastic Strategy. And it really aims at promoting new voluntary action that are aimed at ensuring that 10 million tons of recycled plastics find their way into new products by 2025. So to date, the Alliance involves around 300 partners along the entire plastic value chain, and it focuses on very different sectors, so from packaging to automotive, building and construction, but also agriculture and electronics, and is working on the 5 thematic areas that you see on this slide. and I will come to design for recycling in a second. So, for instance, first of all, the CPA has identified in a report the untapped potential for instance, collection and sorting systems, but also which are the investment needs that are really key to reach its target of 10 million tons. The CPA is also working on identifying the main, let's say, legal, but also technical and economic obstacle to the uptake of recycled content. Is working to set up a monitoring system for collection and sorting of waste and other processes. And finally, in relation to design for recycling, the CPA is working along two different lines. So in the shorter, let's say, a medium term, is looking at developing, updating, and also revising existing guidelines related to design for recycling. And in the long term is assessing the potential need for the development of a standard at SENEC level. So this is the European, these are the main European standardization bodies. And therefore, the idea is that based on the CPA output, the European Commission is expected to issue a standardization request to SENELEC for the development of standards related to recycled plastics and plastics recycling. And obviously, as Plastics Europe, we believe that the coordination with the value chain is key to progress on the circularity of plastics, and therefore we are engaged in this initiative, and we provided input, let's say, throughout the work streams that the CPA is covering. So on this slide, you are seeing a diagram that I believe exemplifies very well why an integrated approach along the value chain is needed. So the idea behind this diagram is a bit the CPA vision that design for recycling, increased collection, better sorting will all contribute to producing a more reliable feedstock and therefore lead to high quality recycled content. And therefore the definition of guidelines and potentially standards on design for recycling, but also quality of waste, quality of recyclate, and how to integrate them into new product as recycled content will be critical to having products that are better designed for their end of life. So really all the activities that you see along this diagram, along this circle, are interlinked, linked to one another. And in the CPA, this is why in the CPA, the view of different parts of the value chain are integrated to really build the circular economy for different products. So moving on now to the work of our member companies, I would like just to spend a few words on what our members are doing. So here you find on this slide really a snapshot of how they are contributing to the circularity of plastics vision. So you see examples in the development of new products that pertains to very different sectors. So the automotive, aeronautics, obviously the packaging sector, but also electronics. And there are also announcements and developments of advanced recycling technologies and investments that have been made for the production of plastics recycled content, which will be used in consumer products. And in relation to this, Plastics Europe has already announced a significant increase in planned chemical recycling investments. Indeed, we conducted a survey among our member companies, and the result of which have highlighted that our members are really planning to invest more than 7 billion euros in chemical recycling in Europe by 2030. mainly to complement already existing mechanical recycling operations. The part of these investments, we believe, will already deliver some capacity as early as in 2025, since the production of recycled plastics is estimated to increase to 1.2 million tons in 2025 and to reach 3.4 million tons in 2030. And therefore, we believe Plastics Europe can play a really leading role in delivering on the European Commission and the CPA target of reaching the 10 million tons recycled plastics by 2025. So just to conclude, overall, I think that we are contributing both to catalyze design for recycling to accelerate mechanical recycling, but also contributing to the CPA target of the 10 million tons by planning to produce 1.2 million tons recycled plastics for chemical recycling. And in summary, I will just conclude that we believe collaboration and cooperation with the value chain, different stakeholders, partners, and authorities is obviously key in advancing the development of the circular economy in Europe, and that we see a real opportunity in the CPA in capitalizing on its work and knowledge production for that. So thanks for your attention, and that would be my presentation.
Great, Marcia. Thanks a lot. Actually, those documents from the CPA are really a good read. I recommend to everybody that's interested in policy and in plastics to take a look at them. We've definitely used them in our projects. So thanks for them. And it's also encouraging to know that the European Union is starting a process on standardization of recycled plastics, because that's definitely needed. And we're looking at what you're doing to adopt as many as we can that's relevant also to Israel. We don't have any questions, and actually we reached the end of the first half of today. So thanks, Marcia, thanks all the speakers. Hope you enjoyed the first half. We're going on a break now of 20 minutes, and we'll be back at 11:30 Israel time, 10:30 Central European time with interesting presentation of Elena Parisi from a very interesting innovator of chemical recycling from the UK. I really suggest that you don't miss that presentation. Have a coffee, enjoy a break, and we see you in 20 minutes. And welcome back to everybody. Hope you enjoyed your short coffee or a walk with the dog. We are back at the second half of our seminar today, and we start us off with Elena Parisi. Thank you, Elena, for joining us. There have been last minute coordination talks into last night, but Elena is the Sales and Marketing Director of Recycling Technologies, which is a very interesting plastic recycling innovator and solution provider in the UK. Elena, the floor is yours. Thanks for joining.
Thank you. Let me share my screen so we can start with the slides. Thank you. Hey, can you hear me all well?
We hear you and we see the presentation perfectly.
Brilliant, thank you. So let me start by saying thank you very much for having me, and apologies, we had a little bit of time zone confusion, but here we are. So indeed, I'm Sales and Marketing Director for Recycling Technologies, which is a startup based in the UK that works on chemical recycling. And chemical recycling, basically, I'll tell you more about what it is, but really it's about trying to maximize value that is still, residual value still left in plastic waste. So we often like to start by saying that the general public often thinks the plastic is a bad material. But when we actually start comparing plastic packaging with other packaging materials like paper, aluminium, or glass, we can actually see from this first line here, the plastic has a lower environmental footprint in 3 of the major categories. So the amount of fossil fuel that is used to produce plastic, the water that is used, and the overall CO2 equivalent footprint. And so sometimes, we always fight a little bit about the battle for plastic by saying that, plastic is a great material, and actually the challenges that we've got today are not caused by plastic, but they're caused by plastic when it becomes waste. And so when we actually start looking at what is the size of the problem, so let's move away from plastic as a product, let's go into plastic as a waste and maybe mismanagement of plastic as a waste. We have that, for example, in the UK, there are about 4 million tons of plastic waste generated, 32% of which is recycled, according to official sources, but the majority, 68%, is disposed of in other ways. Now, that is a mix of landfill, incineration, sometimes just for burning, sometimes for production of electricity. So that's why you see W energy from waste, or exported. So very often in Europe, or in some countries actually, we do have this little habit of sending it away, so exporting waste, and effectively just giving away the responsibility of disposing properly with it. And the numbers don't really change if you scale up. So for example, moving away from UK to Europe, you'll see that, obviously the generation of waste, or volumes of waste, increases. That's naturally goes with population. But percentage of recycling versus non-recycled doesn't quite change, right? 33% versus 67%. And again, if we scale to a global perspective, 260 million tons of plastic waste was generated, I think this data from 2018, if I'm not mistaken, but again, only 12% of that is recycled globally. So this gives an idea of what is the size of the problem, but also potentially what is the size of the opportunity. And here, what we try to do, or this is the vision that recycling technologies and many of the chemical recycling companies have for the future, for future value plastic, of better management of waste. So I appreciate it's a bit of a complicated slide, so I put some bullet points on the right for you to read, just in case you should, get lost in my presentation. But if we start following from number 1, this is the value chain that we're trying to portray. So we are consumers, we live in our homes, we buy products from the retailers, right? We bring them home, we consume them. And the waste is then brought to a MRF, material recovery facility. Again, different countries will have different terminologies. You might have it sorting center, MRF, plastic recycling center, different terminologies, but the concept is that the waste that you throw at home is brought to a single place, where it's then separated into different valuable items. So today what happens is that out of the plastic bin, only few types of plastic waste are actually recycled. And that is the mechanical recycling loop that you can see from 1 to 2 and back into the loop. So this little circle. And why is that? So mainly actually bottles are recycled. Your milk bottles, your drink bottles, your water bottles, like anything which is basically made of PET or HDPE, which are two polymers that don't degrade very easily. And that's the reason why mechanical recycling companies, what they do is that they wash it, they shred it, they granulate it. And once you have these recycled granules, they put it back into compounders, molders, and back into the retailers. This is what mechanical recycling is as of today. It exists, it's proven, it works. It just works only for 12% of the waste globally. So the problem here is that mechanical recycling has some limitations with respect to tolerance to contamination, with respect to, for example, if plastic is too thin. So, for example, think your salad bag, or your or your crisp packets, for example, that are laminated. That's too complicated for mechanical to handle, and that's where we go into the outer loop. That's what chemical recycling is about. Now, chemical recycling effectively, if we go from 1 to 3 and then to 4, feedstock recycling here, what chemical recycling does is it takes all the residual streams that are left after mechanical recycling and turns it back into oil. Now, that oil is then polished, upgraded by a refinery, and send it back to the polymer producers, number 3 again, or 6 here, and back into the loop. So effectively, what chemical recycling is trying to prove is that we can complement existing mechanical recycling practices by taking the low-grade plastic and bringing it back through a outer, longer loop. So, and we see that there's a lot of legislation that is falling into place, or general demand, both driven by regulatory drivers, but also by private commitments, as we can see here on the right. We are in the UK, and we are not in Europe anymore, but still in the European area and European zone, which is driving very hard this agenda. So, for example, we see that a little bit the situation started escalating in 2017, because Europe, and the UK specifically, used to export a lot of waste to China. And in 2017, China closed the import boundaries, and that started creating a problem of what do we do about. 2021, it just came into place a couple of taxes, plastic tax, which obviously are trying to drive very heavily the agenda, and we've got a whole 10 years worth of roadmap towards trying to incentivize in-house recycling. We also have companies across the world from different backgrounds, petrochemical, oil and gas, but also many brands that have made considerable pledges with respect to chemical recycling in general. So this is a very positive for recycling in general, but chemical recycling specifically, with respect that there is demand and the regulatory drivers are coming into place to actually go in the right direction. So let's go a little bit back, or actually let's zoom into recycling technologies. We often call ourselves RT, recycling technology is very long, but we're a startup, or we were a startup, maybe, let's call it that way, founded in the UK in 2011. And it's basically all been about trying to bring to market an IP that was developed by Warwick University. So we're actually, our CEO in 2011 acquired the rights of research, pyrolysis, like research and paper published by Warwick University, and we started commercializing that ever since. So we're currently developing technology completely in-house. We are effectively trying to bring 1-2 products into the market. Our product is this machine, this modular machine, mass producible machine, which is like a little refinery that works the other way around. So you feed plastic in, you get oil out. As I mentioned, we keep like fighting patents because we are the sole developer of this technology. We're mainly 150 people, or 120, sorry, as of close of last year. 50% of which engineers, give or take, so still extremely technical focus. And we have a number of partners that have joined us along the way from the chemical industry. So you'll see Neste, UNIDO, Cirqpack, but also Trinseo, but also, for example, like institution and venture capitals, Mirova, Ellen MacArthur, and then brands in Unilever, Nestlé, and Mars that work with us in specific projects to try and redesign for recyclability or ensure that they can take accountability of what happens to their packaging at the end of its life. And obviously, we work very, very closely with the UN SDGs, in particular, obviously 9, 11, 12, and indirectly with some of the projects that we also have trying to stop plastic into the water, right? So by creating better management practices for waste on land that inevitably stop leakage into the environment. So this is how does it work? So let's zoom into our product. And that's what I was quickly mentioning earlier, right? So we are bringing a product to market, which we call the RT7000, which is a mini refinery that works the other way around. So if we follow the diagram, what we actually have is that we take plastic like this, like we have it in the photo. So residual plastic that you will imagine you have your plastic bin, you throw all your stuff in it. Imagine somebody else taking out the bottles. What is left? All what is left is basically destined for our machine. It's shredded, it's dried, it's just pre-treated a little bit, and then it's fed into the thermocracker. So thermocracker is also another way of describing the pyrolysis vessel. And the pyrolysis vessel, basically what it does is that it vaporizes plastic. So it's a vessel, extremely high temperature, agitated environment in it, of sand moving, and plastic comes in solid, it vaporizes into a crude oil vapor, basically, because plastic comes from the refining of crude. So, chuck it back, it goes back into crude molecules. I always often, and again, not knowing what is the level of education of the audience in front of me, I always use this analogy. Imagine plastic being a wall made of Lego bricks. It's all perfect, it's all tidy. Then you smash it on the floor and it will break. And it will break into all different bricks, like 1, 2, 3. You can't control the distribution of that. That's exactly what happened with plastics. So plastics is our wall. In the pyrolysis vessel, that's exactly what happens. So temperature breaks it uncontrollably, and what we have is that we then have all these hydrocarbon chains of different lengths into our vapor. We then, if you follow the graph, the diagram here, going into number 4 and 5, what we do is that this gas is conveyed into a series of distillation columns, and we extract different products. Mainly, we extract 2 products: a liquid fraction and a solid fraction. Solid fraction is wax, and it goes into a wax refiner, upgrader, blender, etc. So it's sold to the end market. And then the liquid goes to our partner Neste, and what they do is basically they clean it, they refine it, and they convert about 90% of that into naphtha. Naphtha is the feedstock that is used to produce, with one of the feedstocks that is used to produce plastic, so ethylene and propylene, which then become PE and PP, 2 of the most widely used polymers in plastic packaging. We obviously have, other modules for cleanup of the gases, of the, of all the different, like abatement of flares that we need to have to make sure that, whatever we release is compliant with regulations. And then we have what is called 2 and 3, so regenerating unit and heat recovery treatment. And that's basically a bit the uniqueness of our technology. So we operate with 1 and 2. So 1 and 2 is this dual fluidized bed system, which is proprietary to RT, to us. What we do is that we basically operate with dual fluidized bed to be able to recover the heat continuously. So this process operates on a continuous basis, and to make sure that, you know, again, the heat is constant, we continuously need to resupply heat to the main vessel, to the thermocracker. And the way we do that is that we have an external regenerator. The regenerator unit runs with the off gases. So when, you know, of the yield of the whole process is about 75%, which means that if we put 100 kilos of plastic in, we get 75% of wax, so oil out, as a mix of liquid and solid. And what we then have, it's about a 20% fraction, which is still in a gas form, which we just can't extract. It's still hot, it's still vapor, so we reconvey this back into the regenerator unit, where we burn it as a source of fuel, and that ensures the heat that we need for the whole process to carry on. So we started, as I mentioned, in 2011, where we were founded. Nothing really happened until 2013-ish. And then we had the first rig, first semi-lab scale plant built and started operating in 2013. And that's the market which we say that we've demonstrated like proof of concept. And we've been on a journey ever since to actually continue developing technology. So we produced the first flats, which is the name that we've given to the pyrolysis oil coming from our technology in 2016 in barrels quantity for our partners and the petrochemical industry to start playing with. And that was at the back of the first version of what was back then called the RT700. You can see it on the picture, which is the pilot plant. So that was designed to run at about, again, like 100 kilos an hour, so 1/10 of the scale that we're aiming at, commercial scale. And as inevitably happens in product development, you'll find it's not good enough, something is not safe enough, it's not solid enough. And so in 2018, the new version of the beta plant was actually recommissioned. You can see considerably different. And then we made major upgrades in 2019. And then during COVID, we had a little bit of, some time for restarting, but we effectively the recommission of our beta plant version 2 post-upgrade in end of 2020. And we've just completed the first 5 tons of continuous processing on this new version of the pilot plant a couple of months ago. We are continue to develop, we're an engineering company, we just have stopped, but we are actually now scaling up to the commercial plant, which will be going into Scotland. Again, hopefully, Q1 of 2022, so next year. And we are doing that in collaboration with what is called Cirqpack, which is basically a waste site with already some waste operations there, and we're co-locating our unit, and we're working with Bin Farm, which is the waste management company that owns the whole lot, to supply the plastic to our unit. And I think this was it from me. I see we've got questions. So I don't know if.
Yeah, thanks, and also for timekeeping. We did have a couple of questions on the issue of mechanical versus chemical recycling. And in the minute that we have, I wanted to ask you, when, in your perspective, is chemical recycling the go-to option, the first option, and when would you say that chemical recycling is plenty?
So mechanical recycling is always the best option when you can. For example, if we think about a tea bottle, like a drink bottle, a Coca-Cola bottle, which is 100% clean made of PET, of PET, you would never ever put that into a chemical recycling system for the simple reason that it is recyclable. it does work, and it's not too expensive for the environment or from an economic point of view to recycle it mechanically. The right question should not be how is chemical recycling versus mechanical recycling. The right question here is how is the environmental impact of chemical recycling versus landfill or incineration. So if we think about the hierarchy of these solutions, chemical recycling is not at the same level of mechanical recycling. Chemical recycling is an alternative to incineration, energy from waste, and landfill. Because the material that you can send to one process, mechanical recycling versus chemical recycling, are different. So you will never ever find a mechanical recycler being able at scale to recycle crisp packets, for example. Why? Because if you open that, or chocolate wraps, you have aluminum inside, then you have a layer, a barrier layer, EVOH, PVC, whatever that is, and then you have like a polymer, like a polyolefinic layer, PE usually. Just that material, there is no way that mechanical recycling with mechanical means can separate that and clean that. So what happens is they just get rid of it, right? So, and I think this is a very important point that needs to come across, and I think it also answered the second question, right? How to address the risk of chemical recycling competing with mechanical recycling. It's not actually.
We have just a few seconds. So yeah, what you're saying is indeed that chemical recycling is the second alternative if mechanical recycling was not able to tackle the package or the problem or the plastic.
Yeah.
Perfect.
Exactly. They're two complementary situations or solutions.
Perfect. Interesting, and a very heated debate, of course, in the world of recycling, chemical versus mechanical and the environmental impacts, etc. But we're going to hear more actually about chemical recycling, I think tomorrow, from an Israeli solution provider. So Elena, thanks a lot also for making it the last minute joining us. And thanks for your presentation here today. Sorry we didn't have more time. We move onwards now to Marina Kreutzinger. She's a researcher on packaging at the FH Campus Vienne. That's the largest university for applied sciences in Austria. And Marina is going to talk with us about packaging techniques to improve sorting.
Thank you. So you can see me and you can hear me clearly?
Yes.
Yes, perfect. So I will share my screen with you. Okay, perfect. So now we can start. So as said, I'm a researcher at the University of Applied Science. My focus is on sustainable packaging, especially on recyclability of packaging and the whole sustainability assessment. So I will give you a short overview of the University of Applied Science, our outcomes, recent outcomes in the last month. And then we go into the topic of sorting and collection, and of course then packaging recommendations. The University of Applied Science is located in Vienna, the capital of Austria, in the center of Europe. We have around 7,000 students in, so the numbers are from 2020, and we have 61 study programs. Our department is the Department of Applied Sciences. This includes our section, the Packaging and Resource Management. We hold two part-time bachelor degrees. One of them is Packaging Technologies, and the other is more the focus on the sustainable management of resources. We also hold a part-time international master degree, Packaging Technologies and Sustainability. It's for an international audience, so it is also in English. So I would look forward for any applications here, maybe. So what is our research focus? As I said, we are focusing on sustainable packaging. This includes design for circular economy. This also includes packaging safety, zero product loss, and also design for smart solutions. So we always looking or we having a holistic point of view on the sustainability. So the circularity, the product protection should come at first, and also the ecological impacts, indirect and direct. What are our current projects? We are working on guidelines. We have a guideline for the Austrian, German market, and we also have guidelines on different materials. We're doing holistic environmental assessments, as I said, the product protection assessments on recyclability. We recently published a method of recyclability on packaging. We also are working together with the supply chain. So we have a lot of supply chains projects. These are reflex. Here is the focus on flexible packaging. How can they be recycled and sorted? Another project is packed to pack. Here is the focus on closing the loop for PET packaging, excluding PET bottles. So we're looking at cups and trays and containers. And we also have rack to pack. It's quite the same, just for polyolefins. We also have a laboratory where we assess the genotoxicity of packaging and also have in vitro tests on recycling materials. And recently we started on developing compostable packaging. As I said, we are publishing guidelines. In beginning of September, we launched an international guideline with a global recommendation of circular packaging design. We have had a cooperation with the World Packaging Organization and the ECR community. So we have had a global point of view on how packaging needs to be recycled globally. You can find it's for free, so you can find the document on our website. Maybe I will post it afterwards in the chat. And you also can find it on the World Packaging Organization website. So let's go into the topic of sorting. Yeah, first of all, we go into the collection structure. Because before sorting, we need to collect the packaging. So here is just an short insight of the Austrian, German, and Netherlands collection structure. This could be slightly or highly different to other countries. So if you want to facilitate the sorting, or if you as a manufacturer or you have to research on your region, on your country, how is the structure of sorting or the infrastructure of sorting and collection. The sorting processes in packaging. I just want to give you an overview which techniques can be used in several packaging materials. But This also can be slightly or highly different in other countries and for different plants as well. So the sorting process for plastic packaging, first of all, we have a drum screen with holes in it where you can separate its small material from larger material. The ballistic separator separates the 2D from the 3D fraction. The air separator separates the lightweight or the lighter packaging from the heavier, the rigid one. For metal separation of the plastic packaging, we have a magnetic separator and an eddy current separator. So the eddy current is for non-ferrous metals. Then we have a near-infrared spectroscopy, so the NIR, where you can sort the packaging material more specific on the different plastic materials. And also manual sorting, which is quite common in many countries. So the paper sorting is includes also the ballistic separator for bulky paper packaging. We also have an NIR and once again the manual sorting. The metal or the sorting process for metal packaging can be quite different in every country. So, for example, in Austria, we or in Vienna, we are collecting metals and lightweight together. So we just need the magnetic separator and the eddy current separator to separate the metal from the packaging, from the plastic. So now the glass sorting is quite different from the others. So for the glass fraction, we have a crusher. The crusher reduces the sizes of the glass. So there are size requirements for the melting of the glass. Then we have a sieving machine for separating different sizes. We have once again an air separator for the lightweight packaging. We have a magnetic separator and an eddy current separator. And we also have an X-ray spectrum sorter for separating translucent and opaque packaging. And once again, the manual sorting. So now we go more into detail. What does the packaging need to be sorted, or that the chances are quite high to be sorted and come in the recycling loop? So for plastics, we recommend that labels should be under 50% of the surface, because the detection can be quite hard if the label is larger and also have another material. The separation or can be false detected. It's also required that you have a minimum of 2 to 2 centimeters of a rigid package. This could be quite different in other regions for other sorting plants. The range of these holes in the drum screen can go from 2 to 5 or 10 centimeters. So you need to research on the region and also on the country. For flexibles, it should be more than A5. And we also recommend monomaterial because they can be detected quite easier. For plastics, and of course the other packaging materials is the NIR have problems to detect a carbon black packaging. So it will be sorted out and the package won't be won't be recycled at the end. We also know that ferromagnetics over a weight percentage of 1 material will be separated. The magnetic separator is quite strong, and we know that that all over 1% will be separated from the plastic stream. Yeah, the same. So full sleeves are quite the problem if there are if they have another material. We know that the NIR has the ability to detect through the sleeves, but we do not have any thresholds on how thick or thin the material should be. So we currently recommend that or packaging shouldn't have a full sleeve. And in plastic packaging, also residues can be quite hard in the packaging, can be quite hard for the detection in the sorting. Here you have an example. We have here a black, maybe a carbon black packaging. We have an LDPE sleeve, a full sleeve, and a PET bottle, and the bottle will be detected as an LDPE, will come in the wrong waste stream, and PET bottle or the PET material will be lost. So for paper, we recommend natural surfaces, also monomaterials, or paper content over 95%. I know this threshold is also not standardized. We in Austria and in Germany recommend over 95%. I think it's quite different in other countries. Yeah, we also know that composites are a problem. If the paper is laminated on both sides, it won't go through the detection and can't be recycled. Also, metallized surfaces over 70% have problems to be detected, and also again the carbon black. Now we come to metals. It's quite easy. So we have monomaterials, and the direct printing or the paper wraps are recommended, and material gets lost if metal is in composite with other materials. Then we have the glass. For the glass, is recommended that we have small labels and small direct printing, and that the glass itself is highly translucent, and also the recommended colors are white, brown, and green. What could be a problem on the glass is ceramics in and on the glass, ferromagnetics, flip tops, and opaque glass, and also full body printing, and sleeve and large paper labels. Here I have some examples. We have here
Marina, Marina, hi, I'm intervening because we are almost out of time. We have 1 minute or even less, and the focus is, if you have another slide on plastics, that would be great, because we focus on plastic mainly today.
Wait, I didn't hear you.
Just to intervene to say that we have a minute, and and if you have another slide on plastics, the focus is on plastics and not on glass or metal or paper.
No.
So maybe use the last minute for plastics.
Then I will stop here.
I didn't mean for you to stop, but okay.
We just have the glass recommendations and here the blue body sleeve. So yeah, and just in general recommendation.
Awesome.
Okay.
So thanks a lot for your presentation and timekeeping, and also we'll be happy to spread the word about your international master program between our students and generally among students in Israel. So please, I mean, I'd be happy if you offline share with me the information and I can spread the word around. Thanks, Marina, and we go on to Maria Dahl. She's the product developer at AG Westergaard Larsen. That's Scandinavia's largest company within the sector of high quality plastics recycling. So who better to talk with us about the new technologies now available for plastic recycling. Maria, good morning. Thanks for joining.
Thank you so much. And thank you for inviting me to speak a little bit about us and what we do and the new technologies. I have two screens, so I'll look this way, but yeah, perfect. Try to turn my head sometimes. I'll try to share my screen. Can you see it?
It's starting. Yes, you can see it in draft mode.
Oh, maybe I should try. Now, can I see it?
Yes, still in a presenter mode.
Okay,
but if it's,
I can try the other thing. Now?
Coming up, yeah, now it's perfect.
Super. Yeah, so thank you again. I'll talk a little bit about our recycling company, a mechanical recycling company, as well as talk about how we use new technologies as to deal with household wastes. So I am Maria Dahl, and as you told, I work as a product developer here at AG Westergaard Larsen. I'm a material science engineer with lots of passion and interest in circular economy, plastic and plastic recycling. So here at AVL, that's what we call it. It's a very long name. So I do investigation of new applications for recycled material. And I'm also working with implementing more recycled material in the different applications, such as for filaments and furniture. And I also do help customers to find solutions to fit their needs, and also participating in developing new technologies in regard with plastic recycling. Okay, will it change? So yeah, the agenda for my presentation is firstly to talk about who we are and what we do, and then to some new technologies we use here in regard with projects we are working on and so on. And lastly, a little bit about limitations in further development of recycling this type of material. So AG Westergaard Larsen is Scandinavia's largest mechanical recycling company of thermoplastics. We were founded in 1972 in a very small city in Denmark called Mariager. Our core competencies stem from a passion of sustainability and the circular economy. And we have a staff here of combined experience of more than 700 years in recycling and regenerating plastic materials. We are approximately 60 employees, and they have a ground space of 80,000 square meters and 20,000 square meters buildings. So our core business, we do regeneration and grinding of incoming material waste, plastic waste. We do fine milling, so we make powders. We do compounding of additives and different material sources. and we have a new facility where we do washing, drying, cleaning, and sorting of our household waste, our post-consumer. And we also have a laboratory where we quality control our materials. So what we do purchase of plastic waste only from Europe and mostly from Scandinavian countries, and do sale of grind or granulates. This is to all over the world. So we buy the plastic from plastic industries, retail and recycling stations, and different construction companies, mostly polyethylene, polypropylene, polystyrene, PC, ABS, polyamide, and composites. So when we do process our material, we do it with respect to the input material, the type and quality. So if it's really dirty, then we have to do another process compared to what we have to do if it's post-industrial material. We also do some work for the customer if it has some specific demands in regard with colors, the mechanical or chemical properties. And as I told you before, we have a very strict quality control of our materials, both before we process it to assure that we actually get the material that we are paid for, during the production, and after the production of the finished product. We also do provide some contract work for others that are interested in seeing what kind of material do I have here, and should I maybe change it to something else. So we recycle many types of plastic waste. For the 41st years, we focused only on industrial production waste, such as the pipes you see down to the right corner. We do recycling of production failure, offcuts, leftover material from production, as well as post-consumer plastic. This could be everything from used polystyrene fridges to household waste. And this is like the latest focus points that we have here. So to the most important topic of today, new technologies. So new technologies comes from new demands. And as we all know, the greatest demand comes from our planet. We see that there are too much of overconsumption and overproduction and misuse of plastic, which has made plastic getting a very bad reputation. And as I heard earlier, that plastic is a very, very nice material and is more environmentally friendlier than other industrial materials. So hence we are focusing at reducing, reusing, and recycle of plastic as a way to strengthen the circular economy. So until now, focus have been on industrial plastic waste from building and construction sites. Very simple recycling technology involving shredding and extrusion of the plastic, and to some degree washing of it. This plastic waste category covers approximately only 16% of the total plastic production. And this plastic waste category also have has a longer life, up to 50 years. So it's a plastic type that we have kind of a very good respect for. It never ends up in the ocean compared to plastic packaging. So plastic packaging has been and still are the dominant use when thinking about production and use. It covers more than 36% of the production in total. And this plastic category or product category has a very short life compared to the industrial plastic, with maybe days, weeks, maximum month in use. And we can see that the stream of this category has increased more and more for every year. So that is our new topic or new focus. The great consumption of packaging products has given rise to a dominating post-consumer recycled household waste section, which leads for us to solve two problems. The first problem is that new technologies must be developed as to recycle this waste category and get a good quality material. Second one, new technologies must be developed as to recycle for this plastic product category, such as from bottle to bottle. So I will now talk a little bit about some projects we have been going on and still are working on in regard with new technologies on post-consumer recycled household waste. In 2017, we had this project called Development of a Reprocessing Line for Optimal Recycling of Collected Plastic Waste for Households, seen in a circular perspective. We end up with a prototype called Georg and a final production line called Pippi. We always give our production lines and machines names, so it's easier to remember who is who instead of machine 1 and 2. So with this production line, we managed to reprocess highly contaminated material to a material of high quality in terms of mechanical properties. I have a very short video here, which explains it a little bit better, I think. If you don't hear what is said, you just have to tell me. It's in Danish, but with English subtitles. Oh, that didn't work.
I think you have to press the play on the lower bottom.
Yeah, maybe. There, thank you.
Yes.
Can you hear?
Yes. Yeah, but the quality is really bad of the video. I mean, it's not streaming in the right speed, so
Okay.
difficult to see.
Yeah, I can send it. Oh, now I stopped sharing the screen. It's great. I'll try to get it back. 2 seconds.
It's okay, but if you send us the video later, we can share it.
I have a link
everybody.
in the presentation, so it's fine.
Excellent. Yes, we see it again.
It's very good that I have a little bit more time than the others. And it's good that Corona is close to having an end to it. 2 seconds. That. And now I can't find my mouse. There.
It's okay, we can share your presentation for you if you can't.
No, I think I have it here.
Excellent.
And then you can.
Yeah, we can see it in draft mode.
Yeah.
It's in presenter mode now.
In presenter mode. And still in presenter mode.
Yes. Do the same magic that you did last time.
Yeah, I'll do it like this, I think.
All right.
Yeah. So, yeah. I will go further into what was seen in this movie later. So it's not, yeah, you will see it and you will get it. In January 2021, we started with a new project as like a development of the latter one for development of plastic containers in a circular economy, the right quality for the right application. So the goal here was to obtain a high quality material in terms of mechanical properties, as well as removing contaminants, restricting usage of the material in applications such as packaging for hygiene products, as well as cosmetics products. These have a more strict requirements, so it's a more difficult task to solve. In this project, we have developed an after-treatment method for the plastic, which removes up to 95% of the odor molecule limonen. This is a very distinct smell in post-consumer household waste and restrict usage in many products, such as, yeah, very good example, products that should not have any perfume, but still smell like perfume. In August 2021, we went a little bit further and we started this project called Circular Application of Plastic for Food. The goal here was to develop new technologies which makes it possible to use recycled plastic for food contact packaging. As you may know, there are some set guidelines for PET material and the recycling processes for PET. These are not made for polyolefins. These guidelines are, I think, is EFSA, European Food Safety Authority, which makes them. And yeah, so our three-step approach to make a material low on contamination and possible to use for food contact material starts with using post-industrial recycled material and reprocess it into food contact material. Here we will have a full traceability of the material and low contamination. Then we will go a little bit deeper by using post-consumer recycled material from a known source, such as a take-back system, where the customer sent back their products to the seller of the product and we get it afterwards. Here we will have still full traceability, but contamination. And last one, we will use post-consumer recycled household waste to food contact material, where we will have no traceability and contaminated material. So what our plan is to do is to make this challenge testing on the process to see if we can reach the set limits for contamination and allowed contamination in material and follow the guidelines set for PET material. So now I'll talk a little bit about our production line for recycling post-consumer recycled household waste. Pippi, we were inspired by a Swedish children book, which and she has this famous quote saying, "I have never tried that before, so I think I should definitely be able to do that." And we think that this was a hard task, but we should do it anyway. So the production line, it starts with macro grinding of the incoming material or the waste, as you can see down in the left in the container. We then have a pre-wash of the material. This is to reduce the amount of organic compounds such as dirt in the material. Microgrind it into a processable size of the flakes. We then remove foil by a new technique we have made in-house to increase the quality of the output material. We have 2 batch washes that are used for reducing smaller substances or contaminating substances on the flakes with a wash in hot water. We then have a density sorting in water where we can separate material with a density higher than water from materials with a density lower than water. We are focusing only on polyethylene and polypropylene when in regard with post-consumer recycled material. And then we remove, of course, the material that has a density lower than water. We have a second batch wash doing exactly the same as the first batch wash. We found it to be better if you had 2 than 1 long, so that was what we did. Then we have a thermal treatment. This is what we have been working on in the second project on household waste material. Here is where we can remove to a great extent the contamination and substances inside the polymer matrix. It can be oils and other hazardous substances. We then have a near infrared sorting machine that sorts by color and polymer type, so we can achieve a very high purity in regard with separating polyethylene and polypropylene. And then, of course, extrusion of the material, so we get these homogeneous pellets. So we do meet some limitations in regard with future developments. The first one, as I talked a little bit about, is the one regarding guidelines with respect to food contact. So there are none guidelines for these polyolefins. So what we are doing now with our food contact project is to kind of be in front of what is actually allowable today, and be, yeah. So when they say, here you have a guideline, we will be there ready. We need improved waste sorting at waste sorting facilities. This is in terms of polymer purity and production efficiency. We do, depending on the source of the waste, have a pretty high degree of waste when we let the material go through this production line. So, and what can we do when we stand there with materials we can't use? Often we send it to other plastic recyclers. It could be PET, or we have to send it to incineration. And that is one thing we really don't want to do. And we have also seen that the chemical recycling companies, they can't even recycle the material we are left with, which we can't recycle. So yeah. Lastly, the quality of the input material affects the quality of the output material. So when we take the material through our production line, we can end up with, let's say, we can reduce the amounts of contaminants with 90%. But if there are a lot of contaminants in the input material, or impurities such as other polymer types, of course, the output material will have a higher degree of impurities. Lastly, we need more focus on design for recycling. Some items today are not mechanical recyclable. It could be several layers material consisting of different polymer types, having additives that are not wanted for further recycling. We cannot extract that, or different types of fillers. So as I told, alternative technologies, we can send it to them, such as chemical recycling, but we do not know if that is environmentally or economically reasonable. Yeah, I think that was all I had. The movie should take some time, but yeah.
Yeah, I was going to say that we saw Pippi and we're very curious now to see George, but we couldn't.
Yeah. We'll see later.
Yeah, we will send the clip around. Curious about of course, about this haven't been done before project with food quality.
Yeah.
How do you work with other entities except you? I mean, who are your partners on this project? Because there's a tracing element and a logistics element involved here.
We are working with different producers or plastic product manufacturers, such as I can give an example of Arla. They make bottles for milk, or packaging for milk, and yeah, many other types of that. So we start with a take-back system for them. So we have this post-consumer recycled material, but with a known traceability. And they will test their materials. But we also, as I told you, we know that it won't be possible before EFSA has set these guidelines. So it'll be, yeah, we will just prove that it's possible.
Technically.
Yeah, that is what we aim to.
Are retailers involved at all at this stage? Shops
not yet.
Not yet.
No.
Okay. Very interesting to follow on this project.
Yeah.
Thanks a lot for the presentation and for everything else that you shared with us.
Thank you so much.
Welcome to join us for the last presentation today. and that's from Martine Brandsma. She's the director of the Dutch National Test Center for Circular Plastics, new center. And Martine is going to talk to us mainly about testing, which is another element really needed and that we're curious about in Israel. Martina, good morning. Thanks for joining.
Good morning. Thank you for having me. I'm really pleased to join you today. And indeed, I would like to take you through the development of the NTCP and especially also the projects that we are working on. So I will also do this technical trick by sharing my screen. I guess it's shared now, and if I'm lucky, it's in presenter mode. Why is this doing it? Huh?
At least it's doing it to everybody.
That's true. Now it's good.
Yes.
Okay. So thanks again for having me. And my name is Martine Brandsma. I'm the director of the National Test Center for Circular Plastics. It is the colorful building that's on your screens now. The architect came up with this idea stating we are located at an industrial area, but stating that all these industrial buildings are quite boring, so to say. He also mentions that plastics in some cases had quite a negative connotation for a lot of people, and what's happening inside here is really positive. And basically, you could see these all these little blocks as randomly found Lego blocks that eventually turned into this building where we work on circular plastics. And if we break it down, we could build up a new building again. That's the idea of the architect. We're going to talk today about research, development, and testing of recyclable plastics from household waste. And basically, I would like to take you through some of the rationales behind setting up this test center. We're quite a young organization, but also why there was a need for such a center and what we are especially doing here inside. So who are we? As said, we are a test and research organization for circular plastics, focusing on the bulk waste streams. So mainly household waste streams, the material Maria just talked about. We are a not-for-profit organization. So basically, we are not in it for the profit, but we are here to support the market in the challenges that they have. And a really important asset is that we are fully independent. So basically, there are no owners or shareholders of the NTCP. And that means that we are open to all the different players in the recycling chain, from brand owners, retailers, sorters, recyclers, also technology providers, policy makers. They all come over here for their challenges, and we are operational since May of 2020. Since that time, we've worked for all these stakeholders in the chain and performed projects for them. So why are we there? Well, basically, I think that I do not have to elaborate on that too much, because we all agree that the plastic recycling numbers should increase. And basically, in that sense, we are also focusing on keeping the materials in the loop and focusing on, would we be able to move towards more use-to-use recycling? For example, would we be able to keep certain packaging materials also in this type of category of packaging or whatever use, and not and make garden benches or garden chairs, because at a certain point there is also enough of those types of materials in the market. And as said, packaging usually is about 40% of the total amount of plastic being used. So and it's used usually only one time. What we saw during the feasibility study that we did is that sorting and washing on a relevant scale, and for us that means on industrial scale, is really an important step if you want to go to a material that you to new granulate material of a certain quality. Maria also emphasized on it in the previous talk. The input quality really has a huge effect on the output quality. So if you start early in the process, and of course that already starts with the design of the package itself, but also on the sorting and the washing part, if you can really improve on that part and decrease your losses, for example, then you can really make a huge step in this total amount of recycled material. And one of the other reasons that we are here is that we really see that it is needed to also accelerate towards implementation on an industrial scale, especially with these enormous amounts of plastic that are there. And of course, we also need to put efforts in reuse and decreasing the amount of plastic used. But with the amounts of plastic that we still have, we really need to make sure that we are also able to implement our findings on an industrial level. And basically, sorting and washing is not only relevant for mechanical recycling, but also in this new, rather new era or mechanical recycling, in this new field of chemical recycling. Also, a certain amount of sorting and in some cases even pre-treatment is needed to make the material fit for these chemical processes. So basically, to give you a short idea about the development of this center, in the end of 2018, we started based on some needs in the market, figuring out, okay, what would be needed to really set up a test and research facility, because it was not there yet in the market in this field. And we started building the facility physically in 2019. So that moved really fast. And the rationale behind building this facility on an industrial scale, and I already emphasized a bit on that, is that we really foresee in this study, in this feasibility study, that large improvements can be gained if more material ends up in purely sorted streams. Again, laboratory setups are really difficult to scale up to an industrial scale, especially in terms of throughput and volume, but also the equipment sizes. We also noticed that there's a lack of publicly available quantitative data on sorted streams, their composition, the quality, and the yields. And there were no independent organizations available with equipment on a relevant scale to test and research the sorting, and specifically the sorting and the washing process. So there are some setups available in Europe, but usually they are owned by equipment providers, mainly used to demonstrate how well their equipment works. And we rather have a different perspective, really from an R&D point of view. And of course, these results of the quantitative data can act, for example, as input for design for recycling. So really move back to the front of the chain, but also to policymakers. So what decisions do we need to make in terms of balances and fees, for example? So basically, as I said, we started building the facility itself physically in September 2019. And as from May 2020, we are operational as a project organization and built a sorting line on industrial scale. You already saw it on this picture. It is the line behind these windows. So basically, I'm now located here in the building. So what exactly is it that we do? We perform research and development from waste collection to recycling by means of method development, technology evaluation, process development and optimization. We performed control sorting and washing trials. So at this point, we have a small washing setup, and we are currently working on the second phase of the test center to build an industrial size washing line, also completely fit for testing and research, so completely customized for test and research purposes. Packaging assessments. And we have our own research programs on, for example, detection, identification, and classification. So what would sorting in the future look like in 2 to 5 years from now? And how did we set up this business model? Well, basically, as I said, we perform projects for the full chain. So from brand owners, sorters, recyclers, till technology companies. And these projects are usually contract research or contract test projects that we perform for one company. It could be a large project or a small project. So in terms of a few days or a week till a couple of weeks or a few months in total time. And the second part of our activities consists of setting up research programs, because of course, only building these facilities will not give us a sustainable position towards the future, but we also need to continuously develop our knowledge position, keep in charge and keep in line with what technology developments are there in the market. So basically that is where we use these research programs for. And usually these research programs are being acquired either from national innovation funds, for example, in the Netherlands, but it could also be EU programs where we are participating in consortia. And we've also built this year our own research program together with 9 industries and 2 universities. In this case, on sorting and artificial intelligence. And basically, that is our strategy, to keep a balance in our activities where we have continuous flow of research programs in which we can really build and accelerate upon the knowledge position that we have. Of course, we also continuously work on developing new programs, and all the questions that we get directly from all these market projects, we also let them flow back into these research programs to really know how we should develop these programs for the long term. So it is really about, it's like applied testing and research. And with that, we basically also fill in the gap between what is already established technology in the market. And you could say that usually universities are a bit more on this side of the spectrum. So really focusing on game-changing new disruptive technologies that can be implemented in 5 to 10 years from now. And this is really the area where we focus upon. So definitely in between industry and academia. So the current status of the NTCP is that we basically are operational now for 1.5 years, running a lot of different projects. I think we've done over 40 to 45 projects at this point. And we are also working on the realization of phase 2. So we are currently working on building an industrial washing line and started with that project in July 2021. That will also be built from the same design principles as the sorting line. So it fully represents state-of-the-art technology present in Europe at this point. However, it is also for us fully customized, that we can take out all the data, we can sample at every point in the process, we can change the order of the different sorting steps, for example, and in the future also the washing steps. We can also implement new technologies physically into our line to really evaluate new technology developments. So for example, certain marking technologies, if there is a new machine developed, we can physically implement it in our line and evaluate it in combination with already existing technologies. As I said, over 40 projects were performed already. At this point, around 60% of our project portfolio is international. So we are a national test center in the Netherlands. But of course, there's a lot of our customers that do not only produce, for example, for the Netherlands, so a lot of multinationals. And we really also focus on and support harmonization of certain guidelines, etc., throughout Europe, because that really helps in acceleration. And at this point, we work in 4 multiple research programs that we really use for further building our knowledge position. So what is it? What is it then that we do? Well, we always work with real waste streams, of course, with these industrial equipments. Our line has a capacity of around 2 tons per hour. So if you translate it to industry, to industrial sorting installations for plastics, they are like between 16 and 25 tons per hour. So it is smaller, but it includes all the same steps and all the same equipment. One of the examples that you see here is sorting trials. And basically what we developed here together, amongst others, with Recyclas and Cirqpack for the European market sortability protocols, in which we really simulate the process of the total disposal, collection, and sorting. And basically what we can do here is assess whether individual packaging ends up in the right sorting stream and ends up with that in the right recycling stream. Here you see an optical sorter using near infrared technology. This is a standard industrial optical sorter. However, we have customized software in it in which we could read out per pixel what it records, what the spectrum is on how the machine evaluates the packaging. So what type of material the machine sees and why, for example, a certain package is either sorted out of the stream or not. And basically that is what you see here on the right, what we do per step in the sorting process in a sortability trial is, okay, how does the packaging move through this complete sorting process? What are the percentages, for example, that are sorted correctly, and what are the misses, or where does it go wrong? And based on that, we can evaluate whether the package is sorted out in the right stream or not. It was already discussed before, the impact of sleeves. So we also did some work on the sortability of sleeves. We performed sorting trials for that. And indeed, it is the case that if the sleeve is designed correctly, equipment is able to see through the sleeve. However, as Marina just mentioned in her talk, what are the potential thresholds? And that is some work we performed together with the Dutch KIDV, is where we looked into, okay, how can we now make a design decision tree on how these sleeves should look like, what thicknesses could or could not be used, but also what type of paint in terms of reflection and shininess, etc. But also what is the impact, for example, of the disposal process on these zippers that are currently used for sleeves. And basically that in the end has led to a decision tree on sleeve design that is now being adopted by the Dutch Packaging Waste Fund and can be used by retailers and brand owners for their future packaging design. When we started in May last year, one of our first projects that we worked on is on a project for the CFlex consortium. It's a large European consortium. It's a multi-stakeholder consortium with players from the whole chain. And basically they focus on making new film material out of waste film material. And for that, the development of a complete new sorting protocol is needed, because usually flexible and film material is taken out of the stream by wind shifting. So that means that all the PP and PE and some of the PET film, they end up all in the same stream, in the same bucket. And basically, if you want to recycle it, you want to really make the distinction between PE and PP film and take out the PET film. So what we did is we changed the order of the sorting process and proved that with the process that we developed, we were able, with the current infrastructure used in sorting installations, that PP and PE film, and also PE in different gradients and colors, could be sorted separately out of the stream. And with the specially developed quality recycling process of CFlex, meaning that there is also a specific washing and extrusion step, we were able within a year to really go from this new sorting protocol to new packages that were actually also produced. So that was really cool. And to be really clear, at that point we were not able to do the washing and nor the extrusion. So that was done by other partners of CFlex, but we really worked on the development of these new sorting protocols. Another part of our activities consists of determining the composition of waste streams, and that can be household waste streams, but it can also be sorted waste streams. So basically we get a lot of questions from sorters, but also from recyclers. What is exactly in the waste stream and how will that in the end impact, for example, our recycling process? And what effort should we put in to take certain contaminants out if we receive a stream with these specifications? What does that mean cost-wise and in terms of throughput, but also in terms of losses? Because we have a controlled environment, we can really make those balances for these customers. In the study that's on the screen now, we also worked on determining the composition of a municipal waste stream, figuring out for this customer the amount of PP film in there, and determine after a washing and a float sink step what the quality of this material is. And that is what we see on the right side of the screen. This is not the equipment we have ourselves, but together with partners, we can provide this to our customer. And this is what was done at the NTCP. So we really dig into the details of the composition of a stream. We determine the categories of material in there, and then clean up the stream. We have a very small washing facility now, up till around 30 kilos, 30 to 100 kilos we can do. And then the wash flakes were sent to this partner who really made the granulate and made some prototype products out of it to really show to this customer, okay, this is possible to make out of it, but these are also the mechanical properties. I think it is very much in line of what Age Vestergaard Larsen also showed. This is another example of the characterization and compositional analysis of streams. And I just wanted to quickly show it on the screen because it is also a question that is really relevant at this point for different chemical recycling processes. So basically, for example, pyrolysis or whatever chemical processes, it is really important that, for example, there's no PVC or no PET in a waste stream. And basically, the questions that we get at first is, okay, what is in the stream? And second, what is needed to take out these specific contaminants that really impact the next step in the process, the recycling process? One of the other examples of the work that we do that is also moving a bit more towards the future is using new technologies and artificial intelligence on sorting materials. And for that, we've built physically a platform to being able to test and evaluate all different types of sensors available in the market that could be used to characterize objects on other aspects than just the material type, figuring out if we combine the data of those different sensors, whether we could, for example, determine the heritage of a certain packaging. So could we, for example, figure out whether this PP object, for example, in a PP stream has a food heritage or a non-food heritage? And of course, that is really important in the whole discussion of moving towards food-to-food recycling. And I see that my time is almost gone, Avi.
Yes.
So basically, this is also one of the multiple year research programs that we recently started. And our intention is not necessarily to build this technology, but what we built this platform for is really being able to do the research and then make, for example, these new decision models available to the market that develops sorting machines and can adopt them and implement them in the machines. That is really the way we work. And then this is one of the last things I would like to show, because it is really nice. It's just a very, very small part of what we do. But basically, what you hear me say is that we mainly focus on more the technical and the process aspects of sorting and washing and recycling. But of course, awareness at the very beginning is also really important. And that is why, as a side project, we developed an education platform, including a classroom program and this is a sea container. You cannot see it very well, but this is a sea container including all these small recycling machines, and that can move from primary school to primary school, where young kids get educated. They learn about plastics, they learn about sorting, not throwing it into nature, but also what happens afterwards and what you can do with it. And before the summer holidays, 500 children were educated in this container to really learn a bit more about what is going on with plastics. This is our team. And if you have any additional questions, please feel free to reach out to us, either by email or via our website. And we are really happy to discuss with you how we can support your circular plastic challenges. Thank you very much.
Great, Martina. This was fascinating, and I hope the Israeli and international industry that is here on the call, on the webinar, would take use of your services and reach out to collaborate. We are definitely interested in the topic of flexible packages that you mentioned. Also, washing is critical in Israel due to the high price of water and the high standards for the treated water that the washing facility has to stand or comply with. So that these are two very pertinent topics also here. We had a couple of questions, but unfortunately we are out of time. We're actually 2 minutes late, but people can definitely reach out to you on this email or through us, and we'll be happy to convey the questions. So I want to thank you, Martina, and also all the speakers that were with us today, and all the audience that were with us today. And we really welcome you. This was just the first day of a 4-day seminar. We welcome you also to join us tomorrow at 10 a.m. Israel time, 9 a.m. European time. And tomorrow's day is going to be dedicated to recycling, mechanical, chemical. We're going to meet some technology providers. We'll start with an Israeli chemical recycler. And we're going to talk about solutions that combine recycled raw material as well. So thanks again for everybody, and see you tomorrow, 9 a.m. Israel time.
Thank you very much.